Hello everybody, we're back, and today I want to talk to you about global warming and climate change, and specifically today we're going to look at the evidence concerning whether or not the temperature of the planet is going up. So, the main hypothesis we want to look at is the following: that anthropogenic carbon dioxide, in other words, human-created carbon dioxide, has increased the atmospheric concentration of carbon dioxide so much that the average temperature of the Earth is increasing. And this will cause a dramatic shift in regional climate. Now, in our climate systems unit, we have established that if temperature goes up, we expect that we'll have climate effects. So we're really going to focus here on warming itself. And we want to look at a few aspects of the warming question. We're going to take it apart by looking at the following. What's the evidence that the Earth is getting warmer? Okay. Then we're going to look at what's the evidence that CO2 levels are increasing. We want to look at the evidence that CO2 levels actually increase temperature. In other words, we want to say how good is our climate model. And we also want to look at the evidence that humans are emitting the carbon dioxide that would be creating this warming. So that's our task here. I'm excited to show you this and see what your reaction to it is. So let's get going. First, let me say, we've only been keeping climatic records since the late 1800s, maybe 1870, maybe 1880. So it's amazing to me that we can feel confident in the picture we have developed of the climate of the Earth over the last million or more years by looking at various lines of evidence. So I want to talk to you a little bit about that. We can get a picture of temperature over time from many sources. For example, we can look at plankton remains in sediments, and plankton can tell us something about the temperature at that time. We can look at teeny air bubbles in glaciers, and this is especially important in Antarctica, where there is a very long record of ice deposited, and we can estimate fairly accurately how old that ice is, and we can pull teeny bubbles of air that are trapped in those glaciers out and analyze them and get a really great picture of what the atmosphere was like at various times in the past. And we can look at things like pollen from lakes and bogs that are in sediments and see the kinds of plants that were nearby and tell something about the temperature from that. So what have we learned from all this investigation in various fields from various scientists? Well, they all tell a very similar story. And what we found out is that over the past 500 million years, so that's about the time that animals have been around, the climate has been altered by volcanic emissions, by changes in the solar input, by movement of the continents, by the impact of meteors, by changing global air and oceanic circulation. In over 500 million years, we've seen a lot of climate change. And I'm going to come back to that in a little bit. Here's a picture of people taking ice cores in Antarctica. And these ice cores are then cataloged, put in these metal cylinders, and their date of collection as well as their depth, where they were from, are noted, and then the gas bubbles within can be analyzed. Just looking at about the past 900,000 years, which is almost a million years, what we can see about the average temperature on Earth is it's fluctuated from somewhere down slightly below 9 degrees to all the way above 16 degrees. And we right now are somewhere close to that 16 degree mark on Earth. Maybe a little higher, maybe 17 degrees or so. They're called glacial and interglacial periods, and just so you're clear, when the temperatures are low, that's when the glaciers spread out from the poles, and when the temperatures are high, that's when the glaciers disappear. So we have glacial and interglacial periods. We are currently in an interglacial period. If we look at the last 10,000 years, which is roughly the time of sedentary human populations because of the establishment of agriculture about 10 to 12,000 years ago, what we find is that the temperatures have been fairly stable. There have been cool periods in the last 100 to 200 years, but generally speaking, variation has been less than a degree in either direction, very stable period. Now, over the past 1,000 years, this graph actually shows 1,100 years, temperatures have also been stable, although you can see these ups and downs. But once again, the fluctuations have been on the order of 1/4 of a degree, very reasonable fluctuations over time. And you may know that what the next 100 years is going to look like already because you've looked at the right-hand side of this graph. So let's look at the last Well, this is 130 years, and so if we date the Industrial Revolution till about 1840 or so, we'd really love to get the past 170 years, but 1880 is about the time that true global climate measurements started. But what you can see here is that temperatures are going up, especially since about 1960, and they've just been going up, and in the early 21st century, they've continued that trend. So I just want to put in an aside. I call it a short interruption here. And I want to just point out that just because climate change occurs naturally doesn't mean that, hey, everybody, we're free to not care about it. So what, it's changing. It does it all the time. And here are the reasons why we're not free to do that. And they range everywhere from the scientific to the moral. So see which ones resonate with you. 1, past changes in climate have really changed what the planet looks like in drastic ways. There have been several major extinction events where more than 75% of the species on the planet have died. And we're going to study these later. And we're going to find out they caused major changes in the planet when that happens. So that's the first thing. Climate change may have occurred naturally, but what followed was often drastic. 2, it's happening really quickly right now in comparison to previous climate change, even those caused by natural disasters like the meteor impact that killed all the dinosaurs except the lineage that gave rise to birds. So it's happening quickly, and that's a cause for concern. And finally, humans are causing it. It doesn't have to happen. And I'm getting ahead of myself because I'm showing you that the evidence I'm going to show you says to me that humans are causing this warming trend that we've already seen in the data. Let's go on from here. So what's the evidence that the temperature is increasing? Well, right off the bat, right? It's getting warmer, and we saw that in the previous graphs. Yeah, it's getting warmer, and this is not just getting warmer in Des Moines or in Washington, D.C., or in Rio de Janeiro, or in Johannesburg, or in Kuala Lumpur. This is getting warmer everywhere in the whole planet. And I'm going to show you a bunch of data to support that. Every year since 2000 has been warmer than any previously recorded year except 1998. And the only year since 2000 that was cooler than 1998 was 2000 itself. The last 3 years have been the 3 warmest on record, so it just keeps getting warmer. We've noticed a change in phenological spring, and phenological spring is the date of bud break. Aren't you glad that there are people out there who notice when buds break in specific plants and they can compare from year to year? And now we're finding in the Northern Hemisphere, we're about 6 days ahead of where we were 50 years ago. That's the kind of evidence that we could keep looking at and finding if we wanted to, but I'm going to show you some others. A big international group that does work on climate is called the IPCC. They're called the Intergovernmental Panel on Climate Change. And in 2010, they put out a series of updates. And that's before we had the 8 warmest years on record since 2010. They put out the following statements that they consider to be true. Between 1906 and 2005, that's a century, the average temperature of the globe increased by 0.74 degrees Celsius. That's about 1.5 degrees Fahrenheit. From 1970 to 2009, annual greenhouse gas emissions from human activities that were already high in 1970 increased by 70%. From 2000 to 2009 was the warmest decade since records have been kept, 1881. And the current decade is not on pace to be even warmer, but is even warmer. We have only 1 more year in the current, well, actually, no, this is the last year in the current decade, and it's going to be even warmer. So there you go. Arctic temperature has been rising almost twice as fast as the rest of the Earth over the past 50 years. So that's important because there's a lot of ice up in the Arctic, and glacier melting has increased, and there has been increased floating sea ice. Sea level has risen 19 centimeters in the last 10 years. For those of you who aren't good with centimeters, 2.5 centimeters to the inch, so that's almost 8 inches in the last 100 years. Who is the IPCC? Well, I'm going to read you a little bit from their literature. The IPCC is the leading international body for the assessment of climate change. It was established by the United Nations Environment Program, UNEP, and the World Meteorological Organization in 1988 to provide the world with a clear scientific view on the current state of knowledge in climate change. The IPCC reviews and assesses the most recent scientific, technical, and socioeconomic information produced worldwide relevant to the understanding of climate change. It does not conduct any research, nor does it monitor climate-related data or parameters. Thousands of scientists from all over the world contribute to the work of the IPCC on a voluntary basis. The IPCC is an intergovernmental body. It is open to all member countries of the United Nations and WMO. Currently, 195 countries are members of the IPCC. It's an international body with a lot of scientists and economists working on it. Personally, that gives me faith that we should hold their work in high regard. Let's now go and look at some more of the evidence about warming. Here we go. This graph shows the cumulative glacier volume of the world's glaciers. And I think you can see that from 1960 to about 2008, there's a pretty clear pattern of decline in glacier volume. Now, I bet you didn't know that there were people out there who tried to estimate the volume of glaciers in the entire world. But aren't you glad there are? Yeah. Long live the nerds. And in case you're more affected by pictures than charts, here is the Muir Glacier in Alaska, and in the 1948 picture, and then the same picture taken in 2004. And you can see indeed that things have changed. Let's go on. Another glacial issue. Look at this. In 10 years, the summer ice melt in Greenland, which is denoted in orange here in the photograph, changed drastically. Whereas there was very little ice melt in the north in 1992, now there is a huge amount, and the extent of ice melt in southern Greenland is higher. Greenland is the largest island in the world. It's 80% of it is composed of glaciers. It contains 10% of the world's fresh water. How about that? Glacial melting and movement of glaciers is accelerating over time. If the entire thing melts, it is predicted that there will be a 1 meter rise in sea level by 2100 from Greenland alone. Here's summer melt in the Arctic. So September 1979, there's a picture of how much ice there was in September. So this is when the ice is at its smallest extent in the Arctic Ocean. And there it is in 2007. And you can see how happy Russia was to be able to have a sea route over its northern coasts. You can see that the Northwest Passage over North America was almost completely free of ice in 2007. Let's move on. Here's a graph of mean global temperature. I showed you something similar to this before. It's done in Fahrenheit here. And you can see that very clearly since 1980, the temperature has been going up and all the years have been above average. Kind of like Lake Wobegon. U.S. surface temperature. Maybe this is just happening in other places. Nope. U.S. temperature going up as well. You can take a look at this. If you want to look at it longer, stop the video. I'm going to keep moving. Here's another amazing thing. There are people out there who try to figure out how much heat is held in the ocean. Remember, water has one of the highest specific heats of any substance known on Earth. You can see in this graph that the heat content of the ocean in 10 to the 22nd joules, that's a humongous number, right, has been going up and up and up, particularly from 2005 to 2010. Well, from 2000 to 2005, it jumped, and it stayed there since 2005. So it'll be interesting to see when the last 10 years are put in, what's going on there. And don't forget, the oceans serve as a temperature buffer. So the fact that the ocean is absorbing this means that land temperatures have not gone up as much as they would have if the ocean didn't have that heat capacity. The ocean is buffering temperature. What about sea level rise? Is that happening? Yep. Look at this. Here is the graph since 1880, and here is the graph since 1992. It's a pretty linear rise at 3.5 millimeters a year. 3.5 millimeters. That means you will get 25 centimeters or an inch in about 8 years, maybe 7 years. That is some of the evidence that warming is happening and it's having the effects that we would sort of intuit would happen. Temperatures are going up, ice is melting, sea levels rising. It's all there. Let me know if you can think of some other data you'd like to see, and we'll as a class, see if we can find it. Is there something that's missing from that? So that's it for today. What I presented to you today is evidence that the temperature of the world is rising and that it is having the effects on the planet that we have predicted. Next time, we will look specifically at the evidence that the carbon dioxide that is increasing in the atmosphere is of human origin. As well, we will look at some of the effects of the warming on the future. Until next time, study hard.